I'm CK. Since it's close to Halloween 2024 in the US, I'm going to build a surface mount haunting bat. It's probably pretty scary, huh? From WADA, we'll put it together, see if we learn anything from it, see if it's a challenging SMD kit, and I hope you enjoy the video. Let's see what we got. Again, it's the typical WADA overwrap on a plain brown package so they can conserve on a number of different parts they have to carry. It's a seasonal soldering gadget, LEDs, soldering, and it's level 4 because it's surface mount, I assume. 12 orange LEDs, reacts to sound, mountable claws, and it takes 2 2032 button batteries. Let's see what it looks like on the back. We've got a battery holder, looks like a speaker, looks like a USB connection if you want to power it that way maybe, an IC, a microphone, a variable resistor, electrolytic cap, a switch probably, then a bunch of surface mount components. So let's see what it actually looks like. You usually have a sheet of instructions inside also. Bag out, come on, bag out, get the circuit board out, get the paper out, get the box ready for recycling. Let's look at the circuit board first. Looks like a bat, which is probably a good thing. That's where the chip's going to go. That's probably the switch, but I'm not. Actually, that may be the microphone. And we've got some other things that we'll solder. Okay, here's the back, and we've got the variable resistor here, the electrolytic capacitor here, and then LEDs, which will be soldering on the one side so they'll glow through on the other side. LED, a socket here, battery here, LED, bunch of current limiting resistors going to those LEDs. Those are all surface mount. And again, yeah, that's the mic that goes on the front. Okay, it's good to know. Looks pretty straightforward. LEDs and resistors are the easier surface mount components to install. So I don't know how this generates. It may be an STC micro type chip here. I think that's what it'll be. Yeah, okay, so it is somebody's microcontroller. It's got a Motorola logo, I think. But the more important thing, and I don't know if you can see this, see if I can bring it closer. You can see a little swash with a highlighter indicating that it has been programmed. So it is a microcontroller. And we've got bits and pieces. Got some jumper wire, which is probably the claws they were talking about. Socket. Again, it is for USB input. A dial for the variable resistor for sensitivity on the microphone, I'm going to assume. Socket. These are all the orange LEDs, and we've got a bunch of resistors, and they're all different. Oh, some capacitors. I didn't see any capacitors. Where? Oh, there they are. There's 1, 2. Okay, 2 capacitors. They often give you extra surface mount parts because people like me drop them on the floor and lose them. Okay, I'm not going to start putting this together yet. I was just testing something. See what the piece of paper looks like. Typical stuff. Gives you a rough idea of how to solder surface mount stuff. And the battery holder, capacitor, it does not give us a schematic, but with the microcontroller chip, there's not going to be a lot of logic in the circuit itself. The microcontroller is just going to be turning on and off LEDs. There's no op amps, there's no transistors, external transistors doing that. So that's it. Looks like it's going to be pretty straightforward, but some challenging surface mount stuff. Probably a good thing to try out or to practice your surface mount on. I'll get the soldering iron heated up, get my surface mount accessories out, and we'll put this fella together. Let's get ready to do a little surface mount. Now, I'm not actually going to be using my flux today because there's nothing like a integrated circuit that I have to do. So we're just going to be doing basic surface mount techniques. And we're going to start with the resistors. We'll have a little resistor time, as we like to do. We're going to start with the first 5 resistors, which are 270 ohm. So we look into here and we say, where are the 270s? And here they are, because it's marked as 2, they're flipped around, 271, so that's 2 7s, I mean 2 7 and 1 0. So to help us out, we're going to take the resistors out of the paper strip, and we're going to put them in this deep parts bowl. This is actually a stainless steel cat feeding bowl from a company called, what are they called? They're called Basis Pet, and I use them as parts trays for 2 reasons. One, because they're non-magnetic, and I hate magnetized parts trays. The other thing is they're about an inch, 20 millimeters, maybe 30 millimeters deep. So when I dump surface mount components in here, as I just did, they don't fly out onto my workbench. Now you'll see only one of them landed right side up. So what I do is I just pick them up and let them drop. I don't try and flip them over, because that, except for that one, which flipped over naturally. Now you don't have to put the resistors a particular way up. They'll work electrically just fine, whether they have the value side up or the beige or gray side up. I choose to flip them over so the value side's up, just because that's the way I am. And one thing you're going to have to do is clean your tweezer tips quite a bit, because as you solder you'll get flux residue on them there. Now they're all facing the right way up, and we're going to do R1 through R5. So let's find those first. So here we have 1, 2, 3, 4, 5. Now what I do, first I'm going to be using my thinnest solder, which I only use for surface mount. That's this MG Chemical 0.025 inch diameter. Works the best for me. You try whichever you work with. You look at somebody like Diode Going Wild, he uses 0.41 solder, and he uses a plumber soldering iron and does a fine job. So it's up to you. Just practice. I suggest when you're starting out you do the smallest. Now what I'm going to do now is prep the area, and that means I'm going to put a dollop of solder on one pad for each resistor. Now I'm going to take my tweezers, and I got my hands reversed. I got my hands backwards as usual. I'm going to pick up a resistor, put it down. Maybe I should zoom in a little bit. Let me zoom in a little bit. Let me actually turn autofocus off so you can see what's going on. Okay. Now I'm going to take the resistor, slide it into that little dollop of solder I put down, use my soldering iron to melt the solder. There we go. It stays right on there. So that's the easy way to do resistors, and it's the same technique for capacitors and LEDs, so we'll be doing this repeatedly. Just heat that solder up, slide it on, get your iron out of the way, let it cool, always let it cool. If you get impatient, and jerk the, oops, flipped it over. If you get impatient and pull your tweezers away before the solder has fully cooled, the component may not be actually soldered down. And it'll slide away and you'll say, oh gosh darn it, or words to that equivalent in whatever dialect or local language you learned to express displeasure with. Bounce it a little bit. All of them are on, which is great. Now I'm going to do the finishing part, which is first finding where I put my solder. And then you'll notice this one's a little cattywampus. I don't care. Electrically it doesn't matter. As long as I got solder on both ends of it, it's going to be fine. And you'll see I'm just laying solder down in there. Going to double check these connections a little bit. Don't really like that one. Touch that one up a little bit. And go back on the other side because I didn't like the way this one sat down. And there we go. That's the first 5 resistors. And I keep looping my soldering iron cable around my knee. Now the rest are all the same. So I will go ahead and do them quickly. R6, and there are a couple of singletons. So R6, for example, is 10K, so that's 10 with a 3 after it. For 1 0, then 3 zeros, which is this one. And as you can see, they gave me 2 of them, and I only need 1, but they're expecting you to lose some of them because they know how surface mount goes. That goes on R6. R6 is right over here. Gotta flip this one over. Again, it doesn't matter that they're flipped over, but I'm flipping them over just because. And I'll do the rest of the resistors without additional commentary and sped up. And that is all the resistors for today, so resistor time is over for this kit. Now we'll do the capacitors, And the capacitors are unmarked. They do not have their values printed on their bodies. I don't know why. Never have read a reason for that. But the technique will be the same as for resistors. Again, these are non-polarized. These are not electrolytics. So these are going to go at C1, C2, and C5. So we'll find where that is. Where is that? There's C1. There is... That's C5. Where is C2? Oh, there it is. And again, these are really tiny. These are 106s, I think. I mean, 8 or whatever the value rating system is for these. Let me go get that number because I want to be right for y'all's sake. Yeah, these are 603s. This book is my little set of all my spare surface mount in size 603. And where was I? I was going to put this capacitor on there, and what did I do with it, I wonder? Oh, I dropped... There's some over here. What's over here? That's a resistor. So we'll ignore that. Oh, there. I left it on the board. You could have told me that. So these are really tiny. And they always give you an extra one because, as I mentioned, for example, if I were to drop one of these on my floor here, where I have a gray carpet over old concrete, I would never find it again. So that's why you need to invest in books of these. A book of 6, I think these are like 30 bucks for a whole bunch of ICs, a whole bunch of resistors, caps, diodes, transistors, ICs, inductors, and LEDs, and they're like 30 bucks for a book of them. Well worth it. And you want to get a couple of sizes. I have like 1205s and 603s and 805s. When you're building stuff, you'll see the bill of materials, part numbers, and you get a sense for what size you need in your spares locker, or shelves in my case. And that's the capacitors. Next we're going to do the LEDs. Now the LEDs are a little more complicated. I'm trying to see how they're... Okay, good. The boards are often marked in different ways. There's not a real great convention for diode circuit board, LED circuit board marking. I wish there were. But what I'll show you here, and this is going to be really hard to see, I'm getting all the diodes out of their little plastic strip. Now these diodes, as you'll see on the back, let me see how close I can get in on this. I'm going to move the pad a little bit, and then zoom in here, maybe raise this up a little bit. Where are we? Focus on that. Hopefully you can see this little green triangle on the back of the LED, and that points toward the cathode. Just like the diagram you see on a circuit board with the triangle. And on this board, it shows you exactly where the triangle points, which makes it really easy, doesn't it? And this layout looks interesting because I think they picked these LEDs so they will drop through, because they've got a little circular or a little square side where the light comes out. And I'm trying to flip this over correctly. So I'm not going to do the same thing I did before. I'm going to take this, drop it here in that LED hole, and I did it wrong. And it fell all the way through. Thank you very much, LED, for wanting to play games with me. Pick it up again, put it in there. And as you may be able to see, probably not, it's just so tiny, and I just dropped my tweezers, I'll get them. I've got the position 180 degrees out, so I'll just spin it around. So the triangle, green triangle matches the green triangle on the printing on the board. Now again, I didn't prep it the same way because the diode went through the hole, so I didn't want to have it coming the wrong way. Oops. And I just picked it up, and I got to get out of there fast because I'm heating it up too much. Well, that was no fun. Gonna have to heat that up again. This is all a mess now. Let me get back out of here. I'm going to just pull it back out and let it cool off. Back in the hole correctly. This looks like it's the hardest part right now. Now I'll keep my tweezers there to stabilize it. And that's good. Okay. So I think I'll do that for the rest of them. Again, it's a little bit tedious. Oops. I want to make sure the LED, golly gosh. This is not typically the way surface mount LEDs are installed into a little well like that. Gosh darn it. Okay, that's in place, but the cathode is facing the wrong way. Now it's in place, and I will hold it with my soldering iron. Get a little solder on my tip. It's not soldered correctly, but it's soldered enough for me to get the other side, and then I can come back and do that side well. There we go. I'll do this one too while I'm here. Now I'll do all the rest of these LEDs. And since it's well, no, cameras are still running. I'll see how long this goes. I may cut out some of this in editing. In fact, I probably will. So we've got all the major components on, the resistors, the capacitors, the LEDs, and that's how you do it with the soldering iron and solder. You don't have to do that, obviously. You can get solder paste, And a hot plate, a reflow oven, a toaster oven can be used even, and you basically use the solder paste and you glue these in place and then put them in the oven and it flows it out to make the electrical connection secure. I don't do that because I don't have any room for a reflow oven. All my horizontal space is taken up. Now we're putting this USB connector on here. I don't think we're ever going to use this. I'm not sure why we would use it, but maybe to program the microcontroller, which will go in there, an Atmel or STC micro. Now we'll put that on there like that, and you probably can't see this, but there are 3 leads that are connecting to the pads on the circuit board there. But what I'm going to be doing is I'm going to be pressing down on this with my ring finger, grabbing a little solder, checking to make sure my top camera is still on because it went off 3 times in a row while I just started saying those things. And I'm going to solder this leg down, and it's going to transfer heat to my ring finger. No, it did not. Huh. Amazing. Didn't heat me up. Now I'll do the other legs. Again, I'm not going to be using this USB connector for anything because this takes 2 2032 batteries. I guess this is if you want to not use batteries. And there, that's in place. And I'm not going to solder the legs in there. They're connected firmly enough simply by pressure. Now we'll put the battery holder on. If I can find it. Where is it? Oh, there it is. Right in front of my face. And we're not going to solder on this side. We're going to do basically what I just did for the USB connector. I'm going to hold this down with my ring finger. Actually, leave that there. That's good. Making sure it's all even, and it is. And then we'll put the trimmer on, which I assume will adjust the speed of the bat blinking or whatever. And I'm going to solder it from this side also, even though I want to make sure I have the component going into one of the holes in my solder pad so it's not pushed up. But I'll do that this way, just so I don't have too many globs of solder on the visible side of things. And now we're going to do the electrolytic capacitor, which goes right over here at C3. And as you can see, it's a lie flat. So we're going to put the long lead in the plus sign marked hole and lay this down flat like so. So it is actually not higher than the trimmer. And again, I'll solder it from this side so I don't get globs of solder on the other side, or minimize that. I think that's the only, well, we'll have to trim the microphone leads. Never mind, I thought it was the only leads we'd have to trim on this. I'm going to trim these trimmer leads too, because they're sticking out. Now we will put the IC socket on, and it's got a notch in it, and there's a notch marked on the circuit board. Now this one we are going to have to solder on this side. I'm going to do one leg and lift it back up. See, because it's not quite flat on the board. So I'm going to push it with my thumb behind the board, reheat that solder, and it goes completely flat. Do all these legs. I'm going to get up for a minute because I want to make sure I have my 2032 batteries charged. Next, we're going to put the switch on, and the switch will go back here. And again, we're going to, we'll solder it on this side, I guess. And once again, want to make sure it rests in one of the holes on my solder pad, on the back side of my solder pad. Next will be the microphone. I wonder how he wants this to go on. Let me look at the picture. So the microphone goes on the back, does not go on the front. Okay? And it's keyed, and I'm making sure the keying is correct. And that's all sloppy, kind of sloppy, but that's okay, because just like before, I'm gonna do I have this right? I do have it right. I'm gonna do one leg, and it's all tilted, so I will press on it, reheat that leg. Hopefully you saw it move a little bit. Now I'll do the other two. Trim those. And that's what we got. Now we want to put claws on it. That's what this is for. I don't know why we want to put claws on it, but they want to put claws on it, I'll put claws on it. I guess these top claws would be to allow you to hang it, and the bottom claws would probably be to keep it from going up against the wall too much. Now you can bend these any way you want to make hangers and have it stand off from the wall or whatever. Now we will put the knob on the trimmer, and it's got six sides, and you want to drop it onto your bench. Get the sides lined up. Just press it in place. I'm going to assume this adjusts the sensitivity of the microphone. I don't have a schematic, as you can see. And now we put the brains of the operation in. This is, who's this? Yeah, again, it's PIC. So we'll put that in there, making sure the notch on the chip matches the notch on the socket, matches the notch painted on the circuit board. And there we go. Now, as I said, let me go get a couple of 2032s. I'm going to turn out this light. Yeah, in my shop we only use rechargeable batteries, because if we didn't, we'd be going through way too many batteries on projects like this a couple of times a week. So, yep, I thought it needed 2. Oh no, it only needs 1. So there we go. Back off a little bit. And you can see it's got some patterns. 1, 2. Nope, it does not do anything with that. Let me adjust the trimmer. Oh, that makes it go. Oh, okay, that is completely. Well, I'm not 1. I'm not sure what the. I'm not sure 1, 2, 3. I'm not sure what the microphone is. 1, 2. Oh no, I guess it. The trimmer just seems to be setting different patterns. Or not. Well, whatever. There you go. Little spooky bat. What does it say? Haunting bat for you for Halloween. 1, 2, 1, 2. No, again, that microphone doesn't seem to be actually doing anything. It just looks like it's running through a programmed series of steps in the microcontroller code. But that's all good, and we got 1 LED out. Do I have it going the right way? Oh no, I have it going the wrong way. How did I get that? Oh, I see why. I see what I did. I put this one in backwards because I was misreading the triangle, as hard as that is to believe. But I managed to do that. Let me poke this battery out to turn things off, and let's see if I can rework this without eating it. Because one of the problems when you use solder sucker on surface mount stuff is you can suck the surface mount component up in to the solder sucker itself, and this is not working very well. There we go, we pulled it completely out. Now I will turn the workpiece around. Okay, one more time. It's not working. I think I may have overheated it. Or I'm not actually bonded here. Oh, there we go. There we go. Now, after a little quickie rework, we got all the LEDs on. So that's your haunting bat. Some good hand surface mount practice. And I hope you enjoyed the video.